Hi there, my name is Dimitris Harlapidis, and in this video, which is yet another video of my AP Pre-Calculus video series, we will talk about the end behavior of a polynomial function. And we will begin by the graphical interpretation of this entire concept of what we mean by end behavior. In simple words, end behavior of a polynomial function shows what happens to the y values of a graph as the x values tend to plus infinity or minus infinity. And in the AP Precalculus, they like to describe that as when we tend to plus infinity, they say that the x values increase without bound, or that when we tend to negative infinity, that the x values decrease without bound. Regardless, however, how they will state it, the end behavior, once again, is that simple thing. It shows where the y values are going when the x values are extending to the two ends, either to plus infinity or to minus infinity. Now, when the graph is given, everything is super easy. Let's see these two examples. Let's start with the one on the left. We can easily tell that when the x goes to plus infinity, as the x values go more to the right, the y values increase without bound. They go to plus infinity. While when the x values go to minus infinity, the y values also increase without bound. So again, they go to plus infinity. So we can see that this is an option. Both ends can be heading to plus infinity because both ends can be moving upwards. Similarly, on the right diagram, we see that while x go to the right, the y values move downwards. So they tend to minus infinity. While when x moves to the left, the y values still decrease downwards. And this is yet another option. In the AP Precalculus, we use, and we should learn it by now, we use to describe this end behavior by using limits. Limits, in simple words, because it's something new for all of you, shows a tendency. In order to describe when x tends to plus infinity, y values tend to plus infinity as well, we write it like that. Limit of f of x, so the tendency for the y values, that's what it means, when x approaches plus infinity, as we keep moving to the right, is plus infinity. Similarly, limit of f of x, we still refer to the one at the left. When x goes to minus infinity is plus infinity. For the second graph, we would have write it in a limit notation like this. Limit of f of x when x goes to plus infinity is minus infinity, while limit of f of x when x goes to minus infinity is yet again negative infinity. So we have seen so far that both ends can be moving to plus infinity and both ends in a different case can be moving to minus infinity respectively. But these are not the only cases. On the new graph at the left, we can see that as x gets to plus infinity, as the graph extends to the right, the y values move upwards. By using limit notation, this could be written as follows. Limit of f of x when x tends to plus infinity is plus infinity. On the other side, as x goes to minus infinity, y values keep decreasing. So y tends to minus infinity as well. In limit notation, this can be written as limit of f of x when x tends to minus infinity is minus infinity. And to finish with the diagram, the graph at the right, we can see that as x tends to plus infinity, the y values keep decreasing, so they tend to minus infinity. And by using limit notation, this can be written like that. Limit of f of x when x tends to plus infinity is negative infinity. While on the other side, as x gets to minus infinity, the y values go increase without bound. And by using limit notation, this could be written as follows. Limit of f of x when x tends to minus infinity is plus infinity, respectively. What would we like to keep from this video? That end behavior shows where the y values keep getting at while we are moving either to the very, very right, that stands what plus infinity is, or to the very, very left end, which is the negative infinity. Remember to use limit notation. That is all. If you have any concerns, any questions, any things that you want me to clarify again, don't be shy. Leave this question as a comment below the video. As always, thank you for watching.